Okay, I'm good.
Okay, let's demo me first.
Should I start?
Yes.
Start.
My name is Michael DeSalvo, and I'm presenting on behalf of the TND booth for the Spring Hackathon 2017. Who we are: Brian, Mike Smith, Pushkar, and myself. We are engineers in the analytics office in Reston on the Trajectory team.
Cool.
What are we trying to do? Well, as a company, I think we all know that we've definitely experienced the pains of trying to run a monolith within a cloud-based architecture. What this project is making an attempt to do is to demonstrate that we can take individual analytics tasks and turn them into scalable and generally stateless microservices whose concern is only where the data is coming from and where the data needs to go to. The benefits of this are twofold. Tasks can operate within their own execution environment, preventing resource allocation issues, and an environment executing the task can be scaled to a size relative to the data and destroy the task completion. How did we attempt to solve this problem? By taking a widely used microservice framework, Spring Boot, and wrapping a textual near deduplication SDK and REST services. The app is configured to know where the data needs to come from and go to, and to validate expected schemas for input and output objects using Hibernate. This is a diagram that just describes the general application flow. You can spin up a service, ingest, generating signatures for comparison, persist those signatures to an external data store, run deduplication, which will pull the signatures from the data store, compute similarity, and return identified pairs and grouped items for persistence, and then the service can be terminated. What we really want to do is use the right tool for the job. We have a tiny little hammer because our demonstration is using a very small data set on a very small server. To the demo. Go ahead and start Postgres. And we've already pre-staged a database called TND and passed that information to our application, so again it knows where it needs to store the data. I'm going to refresh the schema so that we can see there are no tables here. Go ahead and start the application. And as we can see from the log output, which I'll scroll back up to, that the tables have been created courtesy of Hibernate using the annotations process. Again, confirm that by
Can you talk any louder? Unfortunately it's a noisy room here.
Oh, I can absolutely talk louder.
Good.
So I refreshed the schema and we can see now there are tables were created that we'll need for signature generation and deduplication. So our application is started. And we used Swagger as it was going to be very easy to demonstrate our calls using this tool, and it was very easy to set up using Spring Boot. And so what I'll do is begin an ingestion. And as we can see from the console output, we're inserting our signatures into the database. And we can go ahead and get a count. This is Enron bill wrap. There should only be 542 documents, which we can see here. And now we can start deduplication. So using the post call, we'll use 0.9 as our minimum similarity value. This will give us back a task ID that we can then use to track the task status. Small data set, so it completed pretty quickly. This information just says we considered the entire data set and identified 185 near duplicate pairs, which we can confirm by using our get call. And we have our near duplicate pairs, principal, child, and a similarity score. Additionally, we can identify which documents were not grouped based on the similarity threshold. And we have a list of strings that represent those item IDs. So what I'll do now is I'll stop the application. And I will go ahead and refresh this one more time. And here, you can see Postgres is still up, available. and all of our data is here for deduplication. And finally, our ungrouped. And that concludes our demo. Are there any questions?
Why 0.95 for your threshold?
0.9, I just picked what we would typically use as a default. I think in cat proper we use 0.9 as just the default value. Just felt natural. But you can go down below 0.9. Obviously, performance would degrade slightly just because it's just the way it works with the signatures. You'd have to analyze more data with a lower threshold. And again, I just picked what was their standard default.
So,
and if they're, I'm sorry, go ahead.
So is this framework running in the cloud or on your local box, or where is it running?
This is running on a local box, but the Spring Boot service we can turn it into a jar file and either Dockerize it or put it on a machine in AWS, something that's completely separate from the data store. The power of Spring Boot as well is that there are many options you can use for a data store. I picked Postgres only because it's what I'm most familiar and comfortable with, and I think our teammates would agree. But there are also plugins for using Elasticsearch and Cassandra and any other data store you can think of.
When you calculate the signatures, you persist them locally in this thing, but it throws it away when it's done. Is that correct? Or does it push the signatures back to or can the signatures be pulled back to the data store as well?
The signatures get pushed out to the data store. So in an event where we've already computed signatures for an item, if they're sitting in a database, we could suck them back out. We do persist the signatures for something like incremental TND. That was the point of when we created the SDK a couple of years ago.
Right.
Okay.
All right.